Hello, this is Mrs. Huntley. We're still in Module 1, but we're doing the second part of Module 1, which is about scientific notation, and we're actually using the supplemental sheet. So it should have the gold front. It says Module 1, Topic B, and the front page says Stamp Sheet. If you open up to the very next page, that's the page that we're going to be starting on. And I know there's no space at the top of the page for your essential question. However, I want you to write an essential question. On each lesson, we're going to have an essential question, and we'll find some space to write our summary. Um, the way I'm going to refer to the pages is if you look at the bottom of the page, it says 8WB 8-36. This is actually taken from a different resource. So when I refer to what page you should be on, this is what I'm looking at right here. So we're starting on page 36 because this is in the middle of the module. If we were in our Eureka module, we'd be in the middle of the book. We are in this materials module also in the middle of the book because we learned how to manipulate exponents already, and now we're going to put what we learned in the first part of the module to use. And your essential question here is, how can I use what I know about place value and exponents to write very large and very small numbers in a shorthand? So we're going to start with a review of place value and powers of 10. Now, place value you should have learned probably in elementary school. You might have had something in your classroom that had a table similar to this, and it talked about the different place values. So I'm going to start actually in the middle of the chart. We're going to start here where the decimal place is. So if we start 1 unit to the left of the decimal place, that is our ones. So this is our ones column. The number that's in the ones column is 8. So if we take 8 times 1, that would just be the number 8. Now, what power of 10 or what power of any number do we know equals 1? So hopefully right now in your brain you're going, oh, I know that's 10 to the 0 power. So if I were to write that as a power of 10, it would be 10 to the 0 power. So this next one is given to us down here. It's 10 to the first power, and I'm guessing you might be able to figure out a pattern that's going to be going on here. But just to name this column, this is our tens column. So if we have two digits next to each other, we say that they're in the tens. The next column is our hundredths column. And how would I write 100 as a power of 10? That'd be 10 to the power of 2, because that means 10 times 10 would be 100. The next column, of course, is our thousands, or thousands. Why is it popping back on me? I don't want it to. Okay, we'll just move it up there. I tried to get fancy with the whole animation thing, and it kind of backfired there. So thousands, that's going to be 10 to the third power is 1,000. So 10 times 10 times 10. The next one, 10,000s, that's going to be 10 to the fourth power. You know, for the time being, don't worry about this row right here, the row of numbers, you know, and I'm pointing at it, and I can see that you can't see that. But this row of numbers, for the time being, don't worry about those. We're going to use those in a few minutes when we get done talking, when we get done naming all of our place values and putting in the appropriate powers of 10. So the next one, after 10,000s would be 100,000s. Come on. Why? There we go. 100,000s. And if I were to write that as a power of 10, that's going to be 10 to the fifth power. And then we're going to have millions. And that, of course, is 10 to the sixth power. Then we have 10 millions, which is going to be 10 to the seventh power. 100 millions, which would be 10 to the eighth power. And then the last one is billion, or billions, I should say. And that's going to be 10 to the ninth power. So that's getting larger, okay? That's multiplying by a power of 10. Each time we go up 1, 1 times 10 is 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. 10,000 times 10 is 100,000. 100,000 times 10 is going to be a million. A million times 10 is going to be 10 million. 10 million times 10 is going to be 100 million, and 100 million times 10 is going to be a billion. Now, you don't have to draw those little humps there. I was explaining that to you that what's happening each time we go up in place value, each time we add a 0, what we are in effect doing is multiplying by 100. The same thing goes if we are going down in our place value, going from 10 million to a million, that's dividing by a power of 100 or taking 1/10. So as you move to the right, it's getting smaller. As you move to the left, it's getting larger. Hopefully that makes sense and this is coming back to you. Going to the right of the decimal, it's getting smaller. This is the 10th place. So that would be 10 times, 10 to the negative 1 power, or 1 over 10 to the positive 1 power. Hopefully you're remembering that. 100th place, again, 10 times the negative 2 power, or 1 over 10 times 2. The thousands would be 10 to the, oops, pen's not working, 10 to the negative 3 power, or 1 over 10 to the positive 3 power. They're giving the next one to us. The 10,000ths place is 10 to the negative 4 power. Write it as a fraction, so that would be 1 over 10 to the positive 4 power. And of course, the last one is going to be the 100,000ths place, and that would be equivalent to 10 to the negative 5th power, or 1 over 10 to the positive 5 power. These are, again, equivalent ways of saying exactly the same thing. And actually, a lot of this lesson is going to be filled with 2 different ways or 3 different ways of saying exactly the same thing. So we've finished part 2, where it says fill in the power of 10 in the last row in the table above that corresponds to each place value. Some of them have been filled in for you. We went ahead and finished that up on our own because we did it kind of at the same time. What is the value of 6 in the chart above? So let's find a 6 here. Let's see. 6 is right here. So 6 is in the 10,000s place. So if I take 6 times 10,000, that's going to be 60,000. Okay? I could write that also as a multiplication. I could say it's 6 times, let's see, where is it? Right there. 6 times 10 to the 4th power. This is saying exactly the same thing, okay? And I shouldn't have used, you know what, actually it's okay, because when we're using scientific notation, they frequently show the multiplication as an X instead of a star. But I just did go ahead and change it. Okay, how about the value of 7 above? So let's find a 7. Let's see, it's right here. So it's 7/10. So I could say it's 0.7 or 7 over 10, or I could say it's 7 times 10 to the negative 1 power. All 3 of those, again, are saying exactly the same thing about where this 7 is located as far as what its value is. So this next box is asking us to write each number given below as a single digit times an integer power of 10. The first one's been done for us. So at 30,000, they're saying it's the same as 3 times 10 to the 4th power. Let's come up here and see how they figure that out. The 10 to the 4th power is in the 10,000 spot. Let's see. Okay, 30,000 would be in the 10,000 spot. The other way you can figure it out is look at how many zeros are here. Now, be careful counting zeros, because when we have a decimal, it's different. So actually, I shouldn't say count zeros. Let's count place values. So right now our decimal is here. If I move it to the left 1, 2, 3, 4 times, that's going to be my power of 10. Does everybody see what I did there? Now, when you have a whole number, you are counting the place values, but I don't want you to be necessarily counting zeros, because again, that gets confusing. Let's go ahead and move on to the next one. If we're talking about a single digit times a power of 10, my single digit is going to be the number that starts us. So it's going to be 7 times 10 to some power. Now this is 100. So what power of 10 is equal to 100? going to be 2. Okay, and I know it's 100 because I only have 2 zeros there. Now part C is where we're going to get a little bit tricky. Again, I'm going to get my pen to be a little bit thinner so that I'm not writing quite so fast here. Here's my decimal. I want to move it to be over here, and I want to count how many times I'm moving it to know how many powers of 10. So here's 1, 2, 3, 4 powers of 10. So I can say that this number is equivalent to 5 times 10 to the negative 4 power. Why negative? Because it's a really small number. When it's a really small number, I'm going to have a negative exponent. Remember how we were changing them to fractions and we said it's less than 1? So the next one, D, is also going to be a really small number, so I know my exponent is going to be negative. My digit that I'm multiplying by a power of 10 is going to be 3. Why? Because that's the digit that's given to me here. So it's going to be 3 times 10 to some power. I can count how many times my decimal is moving from where it starts to where I want it to be at the end. 2, 3, 4, 5, 6, 7. So it's going to be negative 7. Remember, when it's a small number, your exponent's going to be negative. When it's a big number, your exponent is going to be positive. So this next one, my whole number is going to be the 8 times 10 to some power. See if you can figure it out. You can use this chart up here. You can move decimals. You can do whatever you want to do. Okay, the correct answer would be to the power of 12. Again, if my decimal's here and I want it to be here, how many times am I moving it? I'm going to be moving it 12. Now this next one, it's in the ones place. So what can I multiply 2 times that's going to be equal to 1? Hopefully you remember. Anything raised to the 0 power is going to be equal to 1. So if I were rewriting that times the power of 10, I would use the power of 10 to the 0. All right, next page. Estimate each number by writing it as a single digit times an integer power of 10. So it's kind of the same thing, but we're talking about story problems now, and we're talking about having to round things. So if I have 499 million square kilometers, 499 is really close to 5, isn't it? The way I would do that is look at the digit next to the one that I'm rounding. If it's 5 or greater, I'm going to round up. If it's less than 5, I leave it where it's at. I don't round down, I don't take away, but I leave it where it's at. So being that 9 is greater than 5, I'm going to round up to 5. And I'm going to multiply this by a power of 10. Let's see, what power of 10? 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8 power. The next one, 1 is definitely less than 5, so I'm going to leave it as 4 times 10 to what power? 1, 2, 3, 4, 5, 6, 7 to the 7th power. Now, if you notice, there's only 6 zeros here. That's why I said it's really dangerous to count zeros. So my decimal starts at the right of my number, and I'm moving it 1, 2, 3 places, 4, 5, 6 places, and then 7 places because I want it to be between the 4 and the 1. So this next one, C, the distance between Pluto and Earth is 4 billion. No. See, I hate when I misspeak. It's really big. Wait, I'm going to make sure that I'm right here. Hang on a second. I should have practiced this before I started. It is going to be 4 billion. 4,670 million miles from Earth. So I'm going to round to a power in the billions. Looking here, 6 is greater than 5, so I'm going to round up to 5. Times 10. And how many decimal places? It's starting here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be to the 9th power. If you notice when I was doing that and I got myself confused, I got myself turned around, I don't know anybody that doesn't get turned around and have to count decimal places every so often to figure out how large or how small a number is. And really big numbers are not something that we, oh, everything got covered up, that we do that often. So I came back to look at the chart real quick and I glanced down here to go, oh, that is the billion spot. So I was okay with what I was saying. It will get easier as I'm in this unit and we're talking about this unit, and I'll be able to recognize things more at a glance. But again, these are not things that we say every day, and even I have got to go back and practice things every so often. I know I'm getting super tight on time, but I'd like you right now to pause the video. You know what? Let's do the next one together because it's really, really small, and then I'm going to have you pause the video. So right now, we're looking at a diameter of an average human body cell as being 0.00012, and I'm just going to say it that way because I would get very tongue-tied trying to say it the proper math way, and it would be hard for you to understand what I'm looking at and what I'm talking about as well. And I didn't mean to move that wiggly like that. Here we go. So my decimal is currently here. If I'm rounding it to a whole number, I would take the first number that's written there. So it's going to be somewhere between 1 and 2. That's where I'm going to put my decimal, is between the 1 and the 2. Now looking at the 2, 2 is less than 5, so I'm going to leave it as 1. I'm not going to round up to 2 here because 1.2 is closer to 1 than it is to 2 on the number line. So if I've got 1 times 10, and it's going to be a negative exponent, and I'm moving it 1, 2, 3, 4 decimal places to the right, so it's going to be a negative 4 power. So what I'd like you to do right now is go ahead and pause the video, see if you can figure out E and F on your own, and then come back and see if you're correct or not. So go ahead, pause the video. Okay, for E, I said it was going to be 2 times 10 to the 7th power. If my decimal's here and I want it to be between the 1 and the 2, I'm going to be moving it 1, 2, 3, 4, 5, 6, 7 decimal places. So that's going to be 2 times 10 to the 7th power. And then the next one, the width of the diameter of a piece of fishing line is really, 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 really tiny. So I want my decimal to go between the 1 and the 7. It's currently between these two zeros, and it's going to be moving 5 places to the right. Now 1.7, that 7 is larger than 5, so I'm going to round up to 2. So 2 times 10 to the negative 5th is going to be where I'm at on this one. Now I'm pushing up against 20 minutes here, so I'm going to end the lesson right here. We are going to do this next example, number 7, in class. We will also be doing the next 2 pages in class. Actually, we're going to be doing the next several pages in class. So those of you that are watching this in HARP, or you're watching this from home, over the next, between class tomorrow and our homework tomorrow night, we're going to be getting through page 42. So don't be in HARP telling the HARP supervisors, oh no, she didn't do that on the video, so I'm not responsible for it. You are responsible for it. You're just responsible for it on your own if you didn't do it when we were all doing it together. Anyway, I hope you have a great rest of your day, and I will see you next time.